Hello coders, I welcome you all. Today in this video we are going to discuss very important concept in natural language processing called the bag of words or BOW for short. In this video we are going to discuss theory as well as practical for the bag of words. But to understand bag of words properly, we first need to cover some very important NLP terms like document, corpus, vocabulary and tokenization. So let's begin with the basics. Let's start with document. A document in natural language processing doesn't just mean a Word file or a PDF file. It simply refers to any piece of text. It could be a sentence like this, or a paragraph, or a review, or even a tweet. So please remember, a document in natural language processing doesn't just mean a Word file or a PDF file. It simply refers to any piece of text like this. It could be a sentence, a paragraph, a review, or even a tweet. For example, here you can see this particular sentence, I love natural language processing. That's a document. So when we group several such documents together, we get a corpus, which is just a collection of documents. In simple words, we can say one sentence is one document, collection of sentences called corpus. So let's take one example. Here you can see sample IMDb movie reviews dataset. So here column 1 is the text where each row is a document and column 2 is the label corresponding to the document beside it. I'm sure you find this document to be very simple and you have a good idea about why your data would be formatted in this way in the real world. Note that we might also call column 1 the inputs to our model, while column 2 consists of the targets. Our goal in this lecture is to figure out how we will convert the documents in column 1 into a numerical representation that would be fit for use in machine learning model. So as I said, here each review means each row is a document and corpus is a collection of documents. So in this case, the 5 reviews together form the corpus. Now let's talk about vocabulary. In natural language processing, vocabulary means the set of unique words across the entire corpus. Let's take one example. Let's say we have these 3 simple sentences. I love NLP, NLP is fun, and I love AI. Our vocabulary would be this one. Unique words only, regardless of repetition, that you can see over here. From these 3 documents means from our corpus, we have created this vocabulary, unique words only from our entire corpus. A vocabulary is the set of all unique words that appear in our corpus. I am repeating, a vocabulary is the set of all unique words that appear in our corpus. But the question is, how do we extract these words from the text? That's where tokenization comes in. Tokenization is the process of splitting a sentence into individual words or tokens. Here you can see this particular sentence is splitted into 3 tokens or 3 words. I'm sure all of you are clear with document, corpus, vocabulary and tokenization. Now let's move on. Now let's discuss a concept known as the bag of words representation. So as you know, text and language are sequential, meaning the order of words matters. Scramble the words and you may lose the meaning. That you can see here. Our first sentence, the cat sat on the mat. If we scramble the words of this particular sentence, then you can see here, mat, the sat, cat, the on. Same words, different experience or no meaning at all. Still, many NLP methods ignore word order and instead just count how many times each word appears. This is called the bag of words model. We only care about word frequency, not order. Now let's take this particular example. As you know, this is our vocabulary that we have created from our corpus. So as you know, each row represents a document and each column represents a word from the vocabulary. I love NLP is fun AI, right? So as I said, each row represents a document and each column represents a word from the vocabulary, unique words, right, from our corpus. The numbers show how many times each word appears in each document that you can see here. In this particular document, I love NLP, I occurs once, love occurs once, NLP occurs once. Likewise, for this document and for this document as well. So this table is called the bag of words matrix. So the idea is very straightforward. We create a vocabulary of all unique words in the corpus. Then for each document, we count how many times each word from the vocabulary appears. The order of words is ignored. We just focus on the presence or frequency of words. That's why it's called a bag, like putting words in a bag and just counting them without caring about their order. So now the question is, why use bag of words? Please remember, even though bag of words ignores the word order, it works well for many text related tasks like spam detection, sentiment analysis, document classification, and topic modeling. Bag of words is simple, fast, and easy to implement, and often gives good results when combined with other techniques. But now the question is, what if a word is not in the vocabulary? Don't you worry, we will discuss all this practically. So first, when we train our model on bag of words, it looks at all the documents we feed it and builds something called a vocabulary. This vocabulary is simple, a list of all the unique words that appear in our training data. So you can see we train the model with these 3 sentences. I love NLP, NLP is fun, I love AI. From this, the vocabulary is something looks like this that you can see here. Now the question is, what happens during prediction? So this is our vocabulary. Now later, when we want the model to make a prediction or analyze new text, it will use the same vocabulary. Let's say the new sentence is NLP is amazing. Now here is the twist. The model will try to match each word in this sentence with the vocabulary we built earlier. Now let's go word by word. NLP, found in the vocabulary, counted. Is, found in the vocabulary, counted. Now amazing, not in the vocabulary. It gets ignored. I am repeating, it gets ignored. So even though amazing is a really strong and positive word, the model does not know it. So it pretends like it never existed. So amazing is not included at all. It's simply missing from the output. So you can see if the word is not in the vocabulary, the model ignores it, and this can hurt accuracy. So before we jump to practical part, let's summarize it. Here is the quick recap. A document is one text sample. A corpus is a collection of documents. A vocabulary is a list of unique words in the corpus. Tokenization is splitting text into individual words. Bag of words represents documents by counting the number of times each word from the vocabulary appears, ignoring word order. It's simple to implement and works well for many NLP tasks. I hope all of you are clear with document, corpus, vocabulary, tokenization, and bag of words. Now let's jump to our practical part where we are going to implement bag of words, and also we will discuss this problem practically. Let's typing together and understand bag of words step by step. First, we have to import required libraries. So let's import from sklearn.feature_extraction.text. We have to import count vectorizer. Using this count vectorizer of sklearn, we are going to discuss how to implement bag of words model. Also we need pandas. So let's import pandas as PD. So here count vectorizer will help us convert text into a bag of words matrix. And here we are using pandas to create a nice readable table. So let's create a documents, 3 documents. I love NLP. NLP is fun. I love AI. So these are our 3 documents. Each one is just a short sentence. Now let's create object of this particular class, count vectorizer, with name cvec. So before we move forward, let's check parameters of this particular class, count vectorizer. Let's put cursor over here and let's press shift tab. You can see this count vectorizer contains this many parameters. Now let's discuss some important parameters. First, lowercase is equal to true. You can see this means all words in the text will be converted into lowercase automatically because it is by default set to true. This helps treat similar words as the same. Next, stop words is equal to none. No stop words will be removed. If you set it to English, that you can see here. If you set it to English, it will remove common words like the, is, and etc. But currently it is set to none and we are keeping it as it is, this one. Now token underscore pattern. So this pattern tells the vectorizer to only keep words with 2 or more characters. We can change this pattern as per our requirement that we will discuss shortly, but currently it tells the vectorizer to only keep words with 2 or more characters. Next, again very important parameter, ngram underscore range, which is already set to 1, 1. This means only single words. This is also called as unigrams. So here single words will be used. If you want to include word pairs, bigrams, then we have to use 2, 2. Means to create vocabulary, it will use only one word. In upcoming videos, we will discuss bigrams and trigrams as well. But currently we are using unigram based bag of words. For more detail, you can check this description. Ngrams, right? Ngram underscore range of 1, 1 means only unigrams. 2, 2 means bigrams. Likewise, please remember currently we are using unigram based bag of words. So this means only single words will be used to create our vocabulary. Now let's move to our next parameter, max underscore features, which is defaultly set to none. This means all words will be included in our vocabulary. You can set this to a number like 1000 to use only top 1000 most frequent words. Currently we are keeping it as it is, none. This means all words will be used. Next, vocabulary is equal to none. So the vectorizer will automatically learn which words to use from the training data. If we already have a list of words, we can pass it to here to fix the vocabulary. That we will discuss shortly. How to pass list of unique words as a vocabulary over here. So let's keep this count vectorizer to its default state. Now let's move on and let's fit and transform the text. For that, we have to use this object dot fit underscore transform, and here we have to pass our documents, and let's assign it to one variable, bow matrix is equal to this statement. Let's execute this cell. Let's check, and here you can see output is sparse matrix. So the reason we use the special types of matrix is because most of the values in the matrix are 0, because most documents don't use most of the words in the vocabulary, right? So using a sparse matrix representation, which helps save memory and makes things more efficient, that you can see here. So if we want to check, we have to convert this into array. So let's paste it over here and to underscore array, and let's assign it to one variable, bow underscore array is equal to this statement. Let's execute this cell. Let's check. You can see over here our bag of words matrix. But let's display this properly using pandas data frame. For that, let me write pd.dataframe, and here let's pass this particular array. Now for the column names, we have to get feature names. For that, we can fetch like this. Evac our object, this one, dot get underscore feature underscore names underscore out. So using this, we can get features, means our vocabulary. Copy this, and here let's pass as columns in our pandas data frame. Let's execute this cell. You can see over here our bag of words matrix. But here you can see I is not part of the vocabulary, which we have discussed over here in our presentation, right? The reason for this is because of the default pattern inside count vectorizer, this one. So as we discussed, we can change this particular pattern as per our requirements. So now to include I in our vocabulary, we have to modify this particular pattern. So let's copy this and let's paste it over here, and let's remove this. So this pattern tells the vectorizer to keep words with one or more letters. Previously, the pattern was keeping words with 2 or more characters. Now just we have changed, and it will tell the vectorizer to keep words with 1 or more letters. Let's execute this, this, and this, and this as well. Now you can see here I is included because we have changed the patterns, default patterns of count vectorizer. Hope all of you are clear with this, right? How to customize token pattern, and our I is included, same like this. So this is our bag of words matrix. So this way we can implement bag of words. As I said, this is unigram based bag of words. Now we are going to simulate a real prediction scenario using bag of words model. Let's assume that the model has already been trained and has fixed vocabulary that you can see here. So now let's print our vocabulary one more time. So this is our fixed vocabulary. So if we have such fixed vocabulary, also we can set to our count vectorizer. So if we have fixed vocabulary like this, we can set to our count vectorizer like this. But as you know, we have already created our vocabulary, this one, right? So assume that a new sentence comes in for prediction. For that, this is our object dot transform, and this new sentence comes in for prediction. NLP is amazing. Let's execute this cell, and as you know, it's a sparse matrix. Let's assign it to one variable. To check this, we have to convert into array. Now you can see, for better readability, let's create pandas data frame. Here we have to pass this, and columns is equal to this, our vocabulary list. Let's execute this cell, and as you can see here, the final vector counts only the words NLP and is. The word amazing is completely ignored because the model never saw it before. It is not part of our vocabulary. So the word amazing is totally ignored, that you can see here. So as you can see, as we discussed, even though amazing is a really strong positive word, the model doesn't know it. So it pretends like it never existed. As I said earlier, in the bag of words, if a word was not seen during training, it's invisible to the model later, that you can see here. As we go deeper, we will learn smarter ways to handle such situations. But I hope all of you are clear with bag of words. Hope you like this video. Please don't forget to subscribe this channel. If you like this video, smash that like button. Thank you very much for watching this video. Take care. Bye-bye. See you in the next video.